Today's lesson is on percent error. Have you ever made a prediction? How many jelly beans do you think are in this jar? This is called a prediction, when you try to estimate the answer. Write down your prediction, and we will be referring to it a little bit later in this video. Can you think of some situations in life where people make predictions and try to be as accurate as possible? Some things I thought of were forecasting the weather to determine what you should wear for the day, checking traffic conditions to decide the best route to travel to school and work, tracking a hurricane to determine where and when it hits land, or even economic trends in the stock market. Accuracy is the degree to which an estimate or measurement agrees with an accepted or actual value of that measurement. You can describe accuracy with a measure called percent error. To find the percent error, you're going to divide the change by the actual number. So this is very similar to our previous lesson on percentage of change. So you're again going to take the larger number and subtract the smaller number, but this time you will always divide by that actual number. Let's take a look at some examples. Alice guesses there are 36 passengers on the bus. The actual number of passengers is 45. What is the percent of error? So again, we're going to take the larger number and subtract the smaller number, but we always want to divide by the actual number. So that was 45 in this example. 45 subtract 36 is 9. And you're going to divide 9 by 45. You will get a decimal when you do that calculation on your calculator. So we're going to take that decimal and move it again 2 places to the right and come up with our percentage. So Alice was 20% off in her guess of 36 passengers. Now, when you're calculating percent error, you do not have to do an increase or decrease. You're simply calculating the percentage of the error. Let's take a look at some additional examples. In example 2, we have a table that has the estimated value, where someone tried to estimate the actual, and then down here we have the actual. So once again, in each scenario, we're going to do some dividing. So we're going to take the difference between the two numbers. So in the first one, it's 45, subtract 40. And we want to always divide by the actual. So in this first one, I'm going to get 0.1, and I notice that that's a repeating decimal. So I can either move that 2 places to the right and give it as a percent, which it's asking me for that here. And I rounded that to the nearest whole percentage. Leaving it as a decimal, it would look just like this. In the second one, we're going to again find the difference. 75 take away 63. Then we're going to divide it by the actual 75. In this case, I get a decimal of 0.16. Moving it 2 places to the right gives me 16%. In the third example, I'm going to again find the difference. This time, the estimated number is larger than the actual, but I still divide by the actual. So 125 subtract 99, that's 26. Dividing that by 99 gives me a decimal of 0.26, which is also repeating on my calculator. Moving it 2 places to the right, and rounding to the nearest whole percentage, it would be 26%. Now let's go back to that prediction you made on the number of jelly beans in the jar. And let's see how close you were to the actual number. The actual number was 125. Let's calculate your percent error based on your prediction. Now my prediction was that there were 80 in the jar. So for myself, I'm going to take 125, subtract 80, and divide that again by the actual 125. Now your estimate is probably different than mine. So make sure that you are calculating your estimate and not mine, unless you had the same as what I did. So I got 125, subtract 80, that's 45. Then I'm going to divide that by the actual, and I got 0.36, which if I move it 2 places to the right, my percentage of error was 36%. Then go ahead and answer the question at the bottom. Was your error within 10% of the actual value? Mine was not. The closer you are to the actual, the better your guess was or your prediction. And there you have it, percentage of error.